Here's an example in which we are starting with a complex number in rectangular form and wanting to change it to polar form. So, how does this work? Well, let me write it down here. Minus 16 minus 17i. This is rectangular form, meaning this is like x and y, right? We could graph it. You don't have to graph it, not at all required. But you could graph it on the complex plane, right? This is the x or real axis. This is the y or imaginary axis, right? The complex plane. And it back 16 down 17. So go back 16 down 17 like that. This would be the point back. Well, it is the complex point. Minus 16, what am I doing? Minus 17i, right? It's back and down. So we want to change that. It's back and down like that. We want to change that to polar form. What's polar form? Well, you're going to have an r here, cosine of theta here, I sine of theta there. So we want to change to polar form. Same dot. We want this same location right here, this spot. We just want to give it in polar form instead of rectangular form. How do we do that? Well, it's exactly like changing coordinates. I'll go to the notes and show you. So this is the 10, 3, 4, 5 notes. Down here it says changing rectangular, number 7, changing rectangular form to polar form. Let me take a picture of it there. This is the notes that are at the top of Module 5 for you. And let me paste them in here where we can see them. There we go. Okay, so here they are. Notice right off it says these are the same instructions as number 2 above. These are the same. So changing coordinates, changing the equation, same thing. Rectangular form to polar, exactly the same. What is it? First, plot the point to see which quadrant it is in. And calculate r equals the square root of x squared plus y squared. So let's do that. So we plotted it. It's in quadrant 3. This is the r, this is the x, this is the y. Right? The x is back 16, the y is down 17. This is a right triangle because it's rectangular. It moves perfectly sideways and perfectly down, makes a right angle. Rectangular. You know how to find r. It's Pythagorean Theorem. So r will be the square root of x squared plus y squared. So that's minus 16 squared plus minus 17 squared. And that's going to be, I don't know, some big number. And so let's try to get it here. And then just go ahead and just use your calculator. Get a decimal, 23.345. I don't know how many, did they say how many places there are? 2 places. So 23.345, I'll just say 23.35. It rounds, right? So we got our r. Now, coming back down to the instructions, so that's all just part A. Plot the point, find the quadrant, calculate r. Did it. Find the angle. How do you do it? Well, remember how this works? The reference angle is the inverse tangent of the absolute value. That'll be the reference angle. Then you got to go find the actual angle on the second step. So let's do it. So the reference angle is inverse tangent of absolute value of y over absolute value of x. So that's inverse tangent. Absolute value of y is positive. This is the y, this is the x, right? Positive 17 over positive 16. So the reference angle, hit the buttons on my calculator. Let's see what we get here. Make sure you're in degree mode, right? We're doing degrees on this one. See how they want degrees? It's a little degree symbol. So I'll write degree mode. I know we change back and forth now a lot between radians and degrees. Make sure you are in degree mode. Okay, I am. So I'm going to hit tangent inverse, 17 divided by 16. I'm getting 40. 46.74 degrees, rounded to two places. 46.74 degrees. That's the reference angle. But that's not the actual angle yet, right? You tracking with these instructions? Where are they? Down here. So that's the reference angle. Now, then find the actual angle depending on the quadrant. What quadrant we were in? The third quadrant. The actual angle is 180 or pi, depending whether you're in radians or degrees, plus the reference angle. 180 plus the reference angle. So third quadrant. Right, we're in the third quadrant right here. That's why we plotted it on the first step. Third quadrant, actual angle. So that reference angle is just, by making everything positive here, we really just put it in the first quadrant. We just found that angle. We found the angle in the first quadrant. That's the reference angle. But now we need to find what is that same angle in the third quadrant, right? That means this is theta here, from there to there, same thing, same angle, right? But we need to find what's the actual angle. That means all the way from 0 degrees all the way to there. That's the actual theta. How do you find that? You got to hit 180, and then you got to add the theta more. That's why it's 180 plus the reference theta. You see that? Because actual angles are from 0. So the reference angle is just in the first quadrant. So 180 plus the reference, which is 46.74. So add that up. Let me see. I'll do that on my calculator. I'm getting 226.74 degrees. So the actual angle, right, that's a third quadrant angle, 226 degrees, right? It's not all the way to 270, but it's more than 180, 226, that's third quadrant. See how we got that? See why that works on that little diagram there? Because here to here is theta. When you make everything positive, like we did here, you get it in the first quadrant, right? Because everything, remember the all students take calculus, everything's positive in the first quadrant. So when we made this negative and negative both positive and did tangent inverse, we got a first quadrant answer. You might think, why did we do that? Why don't we just do the other one? Well, it's because you can't get the other one directly and easily because of all the weird problems with inverse tangent and the restrictions. So you have to do it this way. So you find your first quadrant answer, and that's the same as what goes right there. Why? Because that's the same line off of the x-axis. So it's going to be the same angle. So this is theta. That's our reference angle, but we want the actual angle now all the way to there from 0. That's the actual angle. What's that going to be? We're going to hit 180, right? From there to there's 180, and then theta more. So it's 180 plus the reference theta, and that comes out 226.74. So there we go. So the polar form then is, I'll write it here and I'll move it up there. So polar form is R cos theta plus I sine theta. That's polar form. So you put the R on the outside. What was our R? There it is, 23.35. So that's 23.35 times cosine of our theta, 226.74 degrees, plus I sine of our theta, 226.74 degrees. So there's how you type it in. Yeah, I'll just leave it there. I'm not going to go up. You just type it in just like that. Just fill in the R, fill in the theta. Those two thetas are always the same. You just have to fill it in twice, once for cosine, once for sine. So how do we change then? The same way we change quadrants. It's exactly the same way. You just find your R. Same way we change coordinates, I meant to say, right? You've got to find your reference angle first by the inverse tangent of all the positive stuff, and then your actual angle depending on your quadrant, and you've got it. So that changes to polar form.